But today we will spend mostly on P5, and then we will go on touch base P6, and then start 1.2. I will skip 1.1. Let me write it down here before I forget. I will skip section 1.1 until before starting chapter 2. So in my opinion, 1.1 supposed to be at the beginning of chapter 2. That's my opinion. Okay, well, anyway, we don't do that yet right now. So let's go back to 4.5. The next topic we would like to go over is to add and subtract rational fractions. The basic idea is something we have from pre-algebra. Let's say we try to add 3 over 8 plus 1 over 6. Now, the way we did it, we get the LCD first, right? What is the LCD of 8 and 6? 24, right? The LCD, the multiple of 8, which is also multiple of 6. That's 24. So I will put the denominator 24 here, 24 here. And then I do the equivalent fraction. 8 times what give me 24? We multiply by 3, the denominator. So the numerator we will also multiply by 3. Now, similarly, 6 multiplied by what give me 24? Multiplied by 4. So similarly, on the top, I will also multiply by 4. So what happened in this one step? There are actually 2 things to do. First, we do the LCD. Second, equivalent fractions. Now, once they have common denominator, then we can add them. We can put them together under the same fraction. Now, that's the basic idea from our pre-algebra. Now, what happened then if we have more complicated setting, like let's say number 58. Number 58, we have 3 over x minus 1 minus 5. Now, we see this as 5 over 1. Okay, the LCD will be x minus 1. The LCD is x minus 1. Now then the first fraction, the denominator stays the same, so the numerator will also stay the same. However, for the second fraction, the denominator is multiplied by x minus 1. So the numerator will also be multiplied by x minus 1. Now, the purpose is to get the LCD such that we can put them together under the same fraction. 3 minus 5 times x minus 1. And from there, we go on simplifying 3 minus 5x plus 5 over x minus 1. It's negative 5x plus 8 over x minus 1. Of course, we should try to factor in case something cancels. But in this case, the numerator and denominator cannot be factored further. So that's the rest. Okay, things will get more complicated from here, but you see the transition we have from algebra where we don't have variable. Now we have variable in the denominator, right? But the basic principle is still the same. That for us to add fractions, we need to have common denominator. We need to have common denominator and equivalent fractions before we combine them by adding or subtracting. That's the basic idea, okay? Now, how to execute it in more complicated setting? Of course, then we need to know factoring. We need to be good with distribution, foiling, so on and so forth. Okay, number 62. Number 62, they seems to have different denominator, but if you think about it, the denominator actually simply opposite of each other. You see, one of them x minus 5, the other one is 5 minus x. So what I will do is I will reverse or flip the order of subtraction for the second fraction, or the denominator of second fraction. Now, once I flip that, then I change the sign here. Okay, now why is that, Thomas? Well, because 5 minus x is equal to negative of x minus 5. If you reverse the order of subtraction, we get the opposite sign. Okay, and from here, that's just simply put them together, and nothing to factor, nothing to simplify. Sorry, what? Okay, somebody said that she's not paying attention. Then pay attention. Let me know. Let me know right away if you have question. Okay, number 64. Let me do it down here. Number 64. What happened if we have that? A 2 over x minus 3 plus 5x over 3x plus 4. Now, the LCD will be the product of those two denominators. They're already simple, cannot be factored further. So the LCD will be those two. So I will adjust that. It will be x minus 3 times 3x plus 4, x minus 3 times 3x plus 4. On the numerator, originally I have the 2, but I have 3x plus 4, the new one on the denominator. Okay, so that's what I will multiply on the top also. 3x plus 4. On the second fraction, x minus 3 is the newcomer in the denominator. So the 5x we originally have on the top will be multiplied by x minus 3. Continue on, continue here. That's equal to, they have LCD already. Let me put them together. 2 times 3x plus 4 plus 5x times x minus 3 over x minus 3 dx plus 4. Now, if you think you can put them together and distribute this at the same time, go ahead. Okay, just be careful though. Just be careful, especially if the sign in the middle here is subtraction, especially if that was subtraction. Okay, but for addition, and you feel, as long as you feel comfortable and know that you won't make mistake, then you don't mind to take that additional risk, go for it. Okay. What I will do next is I will distribute. Oops. We'll get 6x plus 8 plus 5x squared minus 15x. The denominator already in factored form, so I leave it like that. The reason is I leave it in factored form because in case later on they are factorable further and cancel. 5x squared minus 9x plus 8 over x minus 3, 3x plus 4. Now the thing is the numerator factorable? Is the numerator factorable? The number's too big and I'm lazy to check. So let me just check the discriminant. B squared, that's 81, minus 4ac. Let me show you how I get that. The b squared coming from negative 9b squared minus 4ac. That's 81 minus 160. Oh, that's negative. So it won't be a square number. So it's not factorable. Not factorable. And therefore, that's the final answer.
Excuse me, Professor.
Uh-huh.
Can you kind of explain what you just did with the red writing? Like,
I compute the discriminant. The
what's that?
discriminant of the trinomial is the b squared minus 4ac. The discriminant is b squared minus 4ac.
Okay, I got
So
it. Thank
that's one way to check if a trinomial is factorable. Further is to check if the discriminant is a square number or not.
you. All right, thank you.
Okay. Okay, let's go on. The parts that we have earlier, the LCD can be seen directly. Now the later part here, I don't think so. Like let's say number 66, we have 2 over x squared minus x minus 2 plus 10 over x squared plus 2x minus 8. Now what you will do first, you factor each denominator. You factor each denominator so that we can see what the LCD is supposed to be. This is minus 2 plus 1 here. This is x plus 4, x minus 2. So the LCD will be what?
X minus 2.
Not only x minus 2, not the common factor, actually least common multiple supposed to be. You need to find an expression which is a multiple of this guy and also multiple of that guy. Then it will be x minus 2, x plus 1, x plus 4.
Oh.
Okay, not the common factor, but the least common multiple. Okay, so once you see that factor, you use it. Okay, once you see a factor with exponents, then you use the highest exponent. Okay, if you have the same base, then you pick the highest exponent. So continuing from there, then I will prepare the space. To do this part, you need to be patient though. Okay, it's not something you look at that and you know the answer right away. No, I've been doing math for at least 30 years, maybe even for 35 years. I still cannot do this by just looking at that. So I can say, whoever said that, oh, I can just do it by looking at that, that person must be lying. Or most likely get it wrong. Okay, be patient, be patient. And then the 2 already up there on the first fraction. What was the one missing originally? X plus 4, huh? It was not there, right? Originally, we have x minus 2, x plus 1 only. So x plus 4 was the new factor, right? So I will multiply the top by that new factor. And then the second fraction, we already have the 10. What is the new factor? The new factor is x plus 1, is it right? We have x plus 1 here. So far, is it okay? Now, let me ask you to do the next step. The next step, you will put them together. You will put them together. Distribute and combine like terms on the top. So distribute first. So it will be 2x plus 8 plus 10x plus 20. Then combine like terms, let me just put it here. This would be 12 x plus only a big over x minus 2, x plus 1, x plus 4. Actually, the numerator is factorable, huh? For the numerator, I have common factor 4. So that's 4 times 3x plus 7 over x minus 2, x plus 1, x plus 4.
I think it's supposed to be 10, not 20.
Oh, you're right. Thank you. Should be 10. Thank you. So that would be 18 instead. Who wrote that one? So the common factor is 2, huh? No, I'm sorry. 3. The common factor is 3 on the top. So I take 3. No, 6. I can take 6 out. So that would be 2x plus 3. Yeah, that's the furthest I can go. Okay, now let me ask you to try. You try this number 68. You try number 68, please. Number 68. 68. This is x plus 1, x minus 1. So what will the LCD be? What's the LCD? X plus 1, x minus 1, that's right. The numerator here stay the same. This guy have 2 multiplied by 2x minus multiplied by x minus 1. These 2 here multiplied by x plus 1. Okay, now you try to do the mid step. I think 2 steps after that. And see if the final answer is 4x plus 1 over x plus 1, x minus 1. Okay, but to fill in the details, please. Let me give you 1 minute for that. Okay, I hope you get the same answer.
Yes.
Okay, good. I think that part is still quite simple, though. That part is still quite simple. Now, the next thing we will do is to do complex fractions. But before I start working on complex fractions, I want to give you some foundation first. Foundation for complex fractions. The first one, something called equivalent fractions. We learned it earlier, equivalent fraction. Basically saying that if you have a fraction, let's say 3 over 4, multiplied by the same number on the top and at the bottom, let's say multiply the top by 5, the bottom by 5, then it will be equal to 15 over 20. And the value of this 3/4 is the same to 15 over 20. We call them equivalent fractions. They look different, but the value actually the same. Okay. In other words, if a fraction multiplied by non-zero number on the numerator and denominator, it will maintain the value. Okay, because, well, if you think about it, you basically multiply by 1, right? So multiplying by 1 will not change the value, but it may change the structure. Okay, now the second thing that we will use later on is multiplying by a fraction by an integer that is multiple of the denominator. Let's say, for example, if I have 3 over 4 multiplied by, let's say, 8. How do we do that? Now, the way we see multiply by 8 means multiply by 8 over 1, and we cross cancel first, right? 8 divided by 4 is, if you don't know this, drop the class.
2.
You don't get offended when I say that, right?
No.
Yeah, in fact, I'm the one offended. If you think you can pass this class, you can step into this class without knowing how to divide 8 by 4. No, you should know that already, I know. Okay, so when we multiply by a number that is multiple of the denominator, the first thing we do is we divide first, okay? The quotient then multiply by the numerator. So we get this is equals to 6. Now let's try again. Suppose I have 5 over 6 multiplied by, let's say, by 24. What will this be? Can you do it visually without writing anything down? Five over 6 times 24 is 20. Okay, because 24 divided by 6 first. 24 is multiple of 6, right? So you divide first, you get 4, then multiply by 5, you get
3.
Okay, now that's the idea. Now, in pre-algebra, we learn the following. Suppose I have 2 over 3 minus 1/2 over 3/4 plus, let's say, 5 over 6. If we have that fraction, we call this complex fraction, and we want to simplify this. There are actually 2 methods to do this. The first one is you follow order operations in which you simplify the top, and then you simplify the bottom, and then proceed from there. Let me show you what I meant. You don't need to write this down. You don't need to write this down. Well, after all, you will have the notes anyway later. So the first method is the traditional method. I do the LCD on the top, which is 6. So this is 4, this is 3. And LCD at the bottom is 12. And then I subtract the top, I get 1 over 6. I add the bottom, 19 over 12. Once you have a fraction over a fraction, then you multiply by the reciprocal of the denominator. Okay? Because this is basically, let me slow down a little bit then, because this is basically 1/6 divided by 19 over 12, right? That's what it actually means. So to divide by a fraction, we multiply by the reciprocal, and cross cancel, we will get 2 over 19. Now that's the standard traditional way. Now I'm not saying that's wrong, but I prefer you to use the second method. Now what is the second method? The second method, we multiply by the LCD of all those fractions. The LCD of 3, 2, 4, 6 is the multiple, the least common multiple of 3 and 2 and 4 and 6. That's 12. Okay, now then distribute this 12 by 2/3. 12 multiplied by 2/3 is what? 12 multiplied by 2/3, 12 divided by 3 multiplied by 2. 4 minus, oh, I'm sorry, it should be 8. 8 minus 6 over 9 plus 10 equals to 2 over 9. So you see 12 multiplied by 2 thirds, that's 8. 12 multiplied by 1/2, that's 6. 12 multiplied by 3/4, that's 9. 12 multiplied by 5/6, that's 10. So because I multiply by 12 over 12, then I basically multiply by 1. I don't change the value, but I change the structure. Okay? That's a lot faster. Now, we will use this idea here. We will use this idea here. Let's say, for example, we do number 72. What is the LCD here? On the numerator, no denominator. On the denominator here, we have LCD for x. So on the top, I will multiply by 4x. The denominator, I multiply by 4x. Let's see what happened on the top. X times 4x is 4x squared. Minus 16x. On the denominator, 4x times x over 4 is x squared, right? That's x squared minus 4 over x times 4x is 16. Now then we factor the top, I factor 4x, and the denominator is difference of squares. So then I get 4x over x plus 4. Number 74 happens to be already in 1 fraction over 1 fraction. So I don't think I will use that method. Well, you still can. Let's do it that way. Number 74. Number 74, the numerator is x squared minus 1 over x. The denominator, so this is a larger fraction, the denominator is x minus 1 squared of x. So the LCD is x over is x. So I multiply the top and the bottom by x. So the top becomes just x squared minus 1. The bottom becomes x minus 1 squared. Then you factor the top, right? Then the final answer will be x plus 1 over x minus 1. Okay, let me give you 30 seconds to fill in the detail. The dot, dot, dot there. See what happened in between. Okay, last one from this part before we go to other topic, still in the same section, number 76. I love this question. Number 76, t over square root of t squared plus 1 minus square root of t squared plus 1 big over t squared. Our problem is we have complex fractions. So let's clean up that complex fraction first. I will multiply by the LCD which is square root of t squared plus 1 over square root of t squared plus 1. Now the denominator will be quite nice. Let me write that one first down. The denominator will be t squared times square root of t squared plus 1. Now what happened to the top left? What will this be here when you multiply by square root of t squared plus 1? That will be simply t, that's right. Okay, minus. And what will this be if you multiply by t squared plus 1? Square root of t squared plus 1. That will be t squared plus 1. But don't forget it is in parentheses though, especially because you have subtraction right in front of that. T squared plus 1. Okay, now then I go on. This is negative t squared plus t plus 1 over t squared square root of t squared plus 1. Okay, but we still have a little issue. We should not have square root at the bottom. And what do we do? Multiply by the conjugate, or in this case by itself, that t square root of t squared plus 1. Such that our final answer will be parentheses negative t squared plus t plus 1 times square root of t squared plus 1 big over t squared times t squared plus 1. I more or less agree. I would like to call that the conjugate, but it is actually not really conjugate because there's no adding or subtraction here. This is the only one I need to rationalize. This is the only one I need to rationalize, and there's only one term. There's not two terms. The denominator is not like t squared minus square root of t squared plus 1. No, we don't have that negative or positive here. No, it's multiplication, so it's only one term. It's only one term. Okay. Now the thing is, I somehow think that your textbook very likely say this can be your final answer. Okay, but your textbook, okay, here. But with me, for me, I will say this is where you're supposed to start. For sure is true. Sure is the accepted final answer. I think I should say acceptable. Okay, well, the one here, your textbook may be okay, but other textbook may not be okay because we have square root on the denominator. Right, but the last one for sure is okay because we don't have square root on the denominator. Okay, go on further. Number 77 to number 82, we will factor the common factor with smaller exponent. Now let's look back to what we have done before. For example, suppose I have x to the 5th minus 7x squared. Then when we do the common factor, we pull the smallest factor out, the smaller exponent out, right? Okay, so I take x squared out, and the first term will be x to the x to the third. And the question is why x to the third? Because 2 plus 3 gives you 5, right? Okay, minus only 7. So we factor the common factor with lowest exponent out, and then the exponent of the terms inside here should make up for the missing the exponent we took out. Now, using that same idea, then how do we do number 78? What is the smallest exponent? -3, right? So I take x to the -3 out, okay? I take x to the -3 out. So what will happen with the first term? It will be x to what power? X squared?
X
No,
squared.
no. Let's try. When you put x squared here, you see what happened to the sum.
Oh.
Oh, it's now 5, right? Okay. Yeah. So -3 plus what equals to 5?
Wouldn't it be 8?
That's right. That's 8. So the exponent 2 there is supposed to be exponent 8. Okay, and sometimes you write it down and then you see, oh, is it right? -3 plus 8, that's 5. Oh, okay, then that's the answer. Minus 5 only, right? Okay, now we will try number 80 now. Let's try number 80 now. But let's observe first what common factor do they have. So they have common factor 2, right? So I can take 2 out. Agree? How about the x? How many x can I take out? We choose the smallest exponent. We can take only one x out. Agree? Now then, how about x minus 5? How many x minus 5 we can take out? Choose the smaller one. -4. -4 is the smaller. Now then, if I take 2x, so 2x already out, right? But x minus 5, I took -4 out. So how many x minus 5 left inside? So -4 plus what give me -3? 1, correct? Or you can just ignore that because if you don't write the exponent, it means implicitly exponent 1. Now then, let's take a look on the second term here. We took the 2 out. So that's -2. We took 1x out, x, and we took x minus 5 to the 4th out. So it's all cleaned up. This will then be 2x, x minus 5 to the -4, x minus 5 minus 2x. That will be 2x, x minus 5 to the -4, -x minus 5. Let me ask you to think about that first. Okay, now last step, which I forgot to do in number 78. The last step, we should not have negative exponent in our final answer. So what I will do is, I will pull the x plus 5, make it to the power of 4, but I put it in the denominator. And actually, I can factor the negative out from the last factor. So let me take the negative out. Let me take this negative out. And I get x plus 5 here. Okay. In number 78, I forgot this. This is negative exponent, so I should not leave it as the final answer. So what I will do, I will get x to the 8 minus 5 over x cubed. That's my final answer. Okay, let's do more. How about number 82? How about number 82? Let me write it down. Number 82, I have 4x cubed, 2x minus 1 to the power of 3 halves minus 2x minus 1 to the power of negative 1 half. The common factor, I have 4 and 2, so the common factor will be 2 there. X cubed and x, so the common factor will be x. And then 2x minus 1 to the power of 3 half to the power of negative 1 half. So to the power of negative 1 half will be the common ones. Let me pull them out. I take 2x minus 1 to the power of negative 1 half. The thing is, can you tell what do we have left inside? Okay, and try to simplify as much as you can. Let me give you 1 or 2 minutes from here. So yes, this will be 2x here, but what happened to the exponent here? That's the thing. What is the exponent here? I believe after this is minus 1. Right? Would the new exponent be 2 for, yes, that's right. It's actually 2 here, not 1. Okay, now the reason is negative 1 half plus what should give you 3 half. Okay, the sum of these two should get you back there. Right, so it should be 2. That's right, it should be 2. Okay, should be 2. Now then, we go on further. Let's simplify. So the guy outside, let me leave that negative exponent for now. Actually, we have two issues, negative exponent, and that's a square root. This is 2x times 4x squared minus 4x plus 1 minus 1. Ooh, that's ugly. So this will be 2x times 8x cubed minus 8x squared plus 2x minus 1 over 2x minus 1 to the power of 1 half. Where does the negative 1 coming from? Coming from here, because I factored the whole thing out, right? Okay, I factored the whole thing out. So there should be 1 there. See, right? Okay. Now, then the last part, we have issue with exponent 1 half at the bottom, because that's basically means square root, right? So what I will do, I multiply the top and the bottom by that square root. times 2x minus 1 to the power of 1/2, such that at the bottom I have 2x minus 1 only. I know it seems to be very ugly, huh? I know. Thomas, will you give us this kind of ugly question? Well, life is full of ugly people, right? We need to get used to deal with those ugly people, and one of them is Thomas. Okay. Well, life is not nice though. So, but and the thing is this. Let me encourage you to say this. What I show you here, very likely you will not see anymore in college algebra in our class, but you will see this a lot in your calculus for business, in calculus in general, Okay, so even though we don't need this right now, I may ask you this kind of question in your quiz. I don't really think I will ask you this kind of question in your test. I have other more important questions to ask. But at least for practice right now, such that when you go to calculus for business later on, you already have that algebraic skill to go on. Okay. Now, let me go on further. Number 84, a bit more. Number 84, I will not do it in full, but I will give you this idea. On the numerator, we have negative of x cubed over 1 minus x squared to the power of 1/2 minus 2x 1 minus x squared to the power of 1/2 big over, so I kind of like write it as a complex fractions. Now then you realize, oh, I need to multiply by the LCD. I have only one denominator here. That's 1 minus x squared to the power of 1/2. That's what I do also at the bottom. Okay, so then you will end up with, on the numerator, you will get negative x cubed minus 2x times 1 minus x squared over x to the 4th 1 minus x squared to the power of 1/2. And then from there you simplify further. But that's basic idea. Okay, that's basic idea. So I rewrite the negative exponent in that fraction, in this fraction here, I rewrite this negative exponent as a fraction. So I have a fraction inside a fraction, you suddenly see a complex fraction, right? Okay, and then once you can see it better, you are able to solve it better. Okay, I will ask you to continue with this, the rest of this as your as part of your suggested homework. So your suggested homework here is from P5B will be number 57 to number 67, and then 71 to 93. Okay, just do the odd one like usual. Now I got an email from a couple students in this class asking me, Thomas, where do you write the homework? In this class, we have two types of homework. One homework is to turn in. Now, turn in homework is visible here. Okay, under assignment. So let's see student view. Okay, you will see this the one to turn in. Now, homework that you need to turn in, I call that quiz. Okay, now how about homework, suggested homework? Now, suggested homework, I actually show that during my lecture. Okay, I show that during my lecture. Like, for example, here, right? Now, the thing is, I have students emailing me, Thomas, can you give me the list of suggested homework? I have to be honest with you, I get pissed off with that email. It's just like, you don't want to go through my lecture, but you want to ask me to summarize that for you. No, I'm not doing that. Okay, if you don't want to watch my lecture, you basically don't want to do it the way I want you to do it, okay, then don't even bother doing it. Okay, now I'm not getting mad to all of you. No. I get pissed off to those some students who it's like not only not attending the class, but don't even want to watch the lecture video. When they watch it, they kind of like skip here and there. Okay, fine. I mean, that's your freedom, right? But at the same time, don't ask me to do what I don't need to do while you don't do what you're supposed to do. It's kind of strange. Okay, yeah. So that's why that kind of email. When I get that kind of email, I just keep on saying, "Watch my lecture video. Watch my lecture video. Watch my lecture video." Okay. Anyone? Oh, okay. That's for you. Remember I have a homework due on Tuesday. Okay, and when it comes to the quiz, the homework that you need to turn in, when it comes to quiz, I would like to actually work together. Okay, I encourage you to work together. Each one of you should show your own work though. Okay, and show it nicely, please. Okay, make it something that when I see, I'm happy to grade it. Okay, and you don't need to rush, at least now. Okay, you need to show the work in a nice way, readable, understandable, neatly. Okay, now that's for P5, P6. P6. P6 is something we have done before. So I will just go ahead with reminding you a little bit. This P6 is on midpoint and distance formula. Between 2 points. So let's say, for example, I pick let me pick number 54, the scariest one. A lot of fractions, right? Are you scared with fraction? If you are, then if you are scared with fraction, then you are normal. Okay, me too. Okay, especially at the beginning of me learning fraction. Every time I see fraction, I just hate it. You know. But at the same time, my teacher actually encouraged me, Thomas, keep on doing fraction. Not only me, the whole class. Hey, you know what? Fraction is hard. Okay, you need to give respect to fractions, right? When you see fractions, just handle it with care, basically. Okay, yeah. It may seem to be out of topic, but I would like to share with you my experience when I first came to the United States 20 years ago. I came to the United States almost at the end of 1999. And when I came to the United States, I stayed with my pastor, okay? And there was one time I went out with him and his sons. As I remember, at that time we went to Ralph or Pavilion, I don't remember. And the cashier was actually having an argument with her supervisor. I remember that very well. What amazed me was that even though she was actually arguing with her supervisor, okay, at the same time, she actually served us with smile. She served us appropriately, okay? So, and I when I look at her, I say, well, I don't think I can do that in Indonesia though. If I get pissed off with one person, I tend to bring it out to everybody around me, you know. And she turns to be someone who can actually distinguish. I get mad with my supervisor, but I still need to treat my customer well. Okay, so she can actually be what I call very professional. Okay, and I want to be that kind of person too. Okay, I can be not happy with my boss, but at the same time, I still treat people, other people, in nice way. Now, sometimes I expect her to see that, oh, you know what, like okay, I can be a very difficult person to deal with at times. Okay, but if I were the staff, or if I were the cashier, and I see, oh, you know what, this seems to be a difficult person to deal with. Okay, will you then not dealing with that person simply because, like, oh, you know what, Thomas is an ugly person, I don't want to serve him? You can't do that, right? Okay, deep in your heart, you may say, you may have you may have this kind of prejudice. This person looks so ugly. Okay, may be very hard to deal with, but it doesn't mean I don't serve this person. Okay, I still need to serve this person, yet be more careful. You see what I mean? Okay, so just imagine if you see I'm I become your customer, let's say, and then I kind of like give you attitude. Okay, and what you do is, like, you just be more careful. Right? Likewise, me too. Me too. Sometimes I have to admit I deal with someone that a student or some students that I think quite difficult to deal with. Okay, but I still need to be professional. That's the thing. Okay, I need to be careful when I say things to that person. I need to be careful when I write an email. Okay, even though I want to be honest that most most of them are actually just my own, what you call it, my own prejudice, my own presupposition, maybe. I kind of like thinking ahead of myself, you know. Okay. Uh, Basically, what I want to say is, when you deal with fraction, okay, we know that it's more difficult, but backing off is not the solution. What we can do is we just do it the way we're supposed to, but slow down a little bit. Okay. I usually say treat fraction with respect. Okay, treat fraction with respect. Now I will start with the, okay, let's do the midpoint first. So the midpoint will be 1/2 of the sum of x's, comma 1/2 of the sum of y's, Okay. Oh, the LCD is 6. Let me multiply the. You see, this is complex fractions, right? So I multiply the top and the bottom by 6. I will get -2 minus 1 over 12, comma. On the y component also 6. Huh? So that will be -2 minus 3 over 12. So that's -3 over 12, -5 over 12. That's -1/4, -5/12. That's the midpoint. How about the distance? The distance will be, let me call it d squared for now. The difference of the y's squared plus the difference of the x squared. So distance squared equals to difference of the x squared plus difference of the y squared. So this is -2 over 6 plus 1 over 6 being squared plus -2 over 6 plus 3 over 6 squared. That will be -1 over 6 squared plus 1 over 6 squared. That's 1 over 36, huh? That's 1 over 36 plus 1 over 36, which is 2 over 36. Oh, the denominator already a square number, so let me just do the square root. This is square root of 2 over 36. That's 1/6 times square root of 2. That's the distance between these 2 points. Okay, your suggested homework from here is a short one. We did that before. Number 47 to number 55. Do the odd ones. Just do the midpoint and the distance. That's for P6. Now, let me jump to 1.2. Like what I said earlier, I will skip 1.1 until we are done with chapter 1. Then I go on with, once right before we start chapter 2, I will do 1.1. Now, 1.2 is on solving linear equation. 1.2 is on solving linear equation. Now, you have done this before. Let me give you some big principles before I do the examples. So I saw one of you already turned in quiz 1, 2, 3, but when I look at your last page, seems like you didn't do it the way I wanted. Okay, so resubmit that. Fix your page 3, whoever already turned it in. Okay, fix your page 3 especially. I didn't really see your page 1 and 2 though, because I thought I already taught that. But page 3, I have not taught it prior to today. So I look at that, and yeah, as I expect, it's not done the way I want it. Okay, some principles. In solving equation, not just linear equation, but solving equations in general. The first big principle, D equals sign. The equal sign should line up. The equal sign should line up. So for example, let's say I have 3x minus 7 equals to 5. Then the next line, the equal sign should line up. Okay, your equal sign should form a line. If it is a bit off, it's handwriting, you know, it's handwritten. So if it is a bit off, that's fine. But what I don't want to see is when your equal sign gets like this, for example, your equal sign comes here and then later on here and then later on here and then later on here. No, I don't want it. I don't like it. And I usually penalize at least half point for that. Okay, line them up. Okay, I had one pre-algebra student so scared of me penalizing her, such that she told me at the end of semester, Thomas, in your class, this is how I survive your equation from me being penalized half point all the time. I always write the equal sign first, and then I show the process. That's what she did. Okay, well, at least she survived. Okay, in fact, she got an A. That's my pre-algebra class though. Okay, now I remember this lady because then she took my pre-algebra, my beginning algebra, got A's, and then intermediate algebra with other instructor got A, trigonometry with another instructor got an A, pre-calculus also got an A, and then calculus 1 got a B. But her calculus 1 got a B because her son was sick like for 2 or 3 weeks sometime in the semester. Okay, well, at least I knew that I was proud to be part of her success, you know. Okay, So first principle, your equal sign should line up. Second, simplify each side before moving terms across equal sign. We'll see that in the second example. The third one is we undo the operations. Not changing the sign. And the last one, the one I hate the most, I'm sorry, I was to the point that most of many times I don't like to penalize points, but eventually you make mistake and I penalize a lot of things. Do not pancake. Do not pancake. Yes, I understand. Most instructors do it that way, but that's not the appropriate way. What I meant by do not pancake is this. I saw people doing this. Oh, I add 7, So 3x equals to 12, and then divide by 3, x equals to 4. See, Thomas, I get the right answer. But no, that's not how you're supposed to show your work, though. Okay, I know what you're doing, but that's not the right way to do it. Okay, that's not the right way. Do not pancake. Do not pancake. Okay, do not pancake. Don't do it. Don't do it that way. Eventually, you will make mistake. And I know pancaking method is very visually entertaining. I agree with that. Okay, but that's a technique you can use only for easy questions. Okay, once you get a tedious question like with fractions, with decimal, then pancake tends to lead to mistakes. So please don't do it that way. Okay, don't do it this way. Don't do pancake. Instead, think this way. Okay, even if I really want to show the work, when I undo my subtraction by 7, I add 7 to the other side. So 3x equals to 5 plus 7, which most of you can skip this step and just come up with 3x equals to 12, right? And then you undo the multiplication by dividing. So 12 divided by 3 equals to 4, right? And of course, you are in college algebra, so you can skip this step. Okay, to skip. And you can also skip this step. Okay. But what happens if we have fractions? What happens if we have decimal, especially with a lot of plus minus thingy? Then you may want to slow down and not skipping those steps. Okay, now let's see more. Suppose I have example 2. 6 times x minus 1 plus 4 equals to 3 times 7x plus 1. Now, I try to emphasize my step number 2. Simplify each side before moving terms across equal sign. So I need to simplify the left-hand side first and simplify the right-hand side. Only after they get simple, then you move across equal sign. Okay, so I will do 6x minus 6 plus 4 equals to 21x plus 3. Simplify this first. Simplify this first. Okay, because you can combine like terms there, right? Simplify that first. So I get 6x minus 2 equals to 21x plus 3. Thomas, that's what I would do. Yes, that's what you're supposed to do. But trust me, I have people showing me the work this way. The following is the wrong way. Now, I will penalize you at least 1 point for this. Okay? I have people doing it this way. 6x minus 21x equals to 3 plus 6 minus 4. Oh, so this person actually moving across equal sign moving this across equal sign without simplifying, fully simplified at first. No, I don't like it. In fact, eventually you make mistake there. Okay? Simplify your life whenever possible. Okay? Don't make it more complicated. Simplify first before you move to the next step. Okay? Don't try to do too many things at once. That is true in math. That is also true in life. Okay? Have you ever seen somebody who seems to have a lot of trouble in his or her life? Now, I'm not saying I don't, okay? I'm not saying I don't have a lot of trouble in my life. I have a lot of trouble, but at least I already try to simplify my life, okay? But if you don't simplify your life and you know trouble always come, I mean, that's life, okay? So if you know that you will have issue here and there and you don't try to fix them, it usually starts from ourselves, you know, if we don't try to fix them, it tends to be actually get more complicated later, okay? Sorry if I talk too much about life, but I think if you have common sense, if you have some common sense, you will see that I just apply what you usually do in your life into our math. It's negative 15, x equals to 5. Divide by negative 15. So x equals to negative 1/3. Now, what happens if we have fraction involved? Let's say we have example 3, number 52. Textbook number 52, 4y over 3 minus 2y equals to 16 over 5. We will also use LCD method here, at which I multiply each term by the LCD, in this case 15. Okay, notice that in an equation, as long as you multiply both sides by the same number, then you will come up with equivalent equation. Okay, the solution for the first equation, let's say if I have the one we have here, the solution for negative 15x equals to 5 is the same to the solution of x equals to negative 5 over 15. Because what? I divide by negative 15 both sides. You see what I mean? Okay. So as long as we multiply or divide by the same non-zero number on the equation, we will have equivalent equation. Now, that's what I do here. That's what I do here. I will multiply by the LCD, but the main purpose when I multiply by the LCD is to get an equivalent fraction without fraction. Equivalent equation without fraction. So 15 divided by 3 is 5 times 4y, that's 20y, minus 30y equals to 15 divided by 5 is 3, times 16 is 48. So negative 10y equals to 48. So y equals to negative 48 over 10. I can reduce by 2. That's negative 24 over 5. Last one. Number, let's say number 68. Number 68, 1 over x minus 2. Now we have a rational equation. Okay, I will multiply by the LCD, but before I get the LCD, I need to factor this first. X plus 3, x minus 2. So what will my LCD be? What will my LCD be? Multiplied by x plus 3, x minus 2. Is it right? Now, don't forget, we are supposed to multiply by non-zero number. In other words, our solution cannot be -3, cannot be 2. Okay? Because if our solution is -3, this will be 0 here. It becomes undefined. If our solution is 2, it will become 0 here and becomes undefined. Okay? Now I multiply by that LCD, then I will get x plus 3 in the first term, 3 times x minus 2 in the second term, and only 4 in the last term. Then from here I proceed as usual. For x minus 3 equals to 4, for x equals to 7, x equals to 7 over 4. Now, of course, you visually check that x is not -3, x is not 2, then that's the answer. Now, your suggested homework from here, from 1.2, I would like you to do from just start from number 41. Number 41 to number 73. Do the outline. Okay? So on Tuesday when we come back, we will do 1.3 and 1.4. We will skip 1.5. Yeah, I think I will do 1.3 and 1.4 on Tuesday, and then on Thursday next week, 1.6 and 1.7. Okay, that's for today. See you then on Tuesday. Don't forget you have one homework due. You have a homework due on Tuesday.